Can you solve this geometry challenge? Here's the question. Given this quarter circle, now let's draw a sector inside of it. And let's draw a green circle. And the question is, what is the ratio of the blue shaded region to the green shaded region? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question is 6. This is different from the answer of an AI. So I will show you the answer of an AI at the end of this video. And now the question is, of course, how do we get 6? And here's the solution. In order to answer this kind of question, we need this key concept. And that key concept is this. If two circles are tangent, then their centers and the point of tangency are collinear. So the important points here are the centers of this figure and the point of tangency. And here are those centers in this sector, this part of the circle. So this is the center, and this is a quarter circle. This is the center, and of course we have here the circle, and of course the point of tangencies. Now, using this concept, we can connect these two centers, and we know they create a straight line. Also, we can connect this point of tangency, this center, and the other center, like this. And now, at this point, let's call the radius of this circle as r. And the radius of this quarter circle, or this sector, is capital R. If we get a relationship between capital R and small r, then we're done. And in order to do that, what we're going to do is from this center of the circle, let's drop a perpendicular segment like this. And now let's focus on this figure. Now, on our figure, we see a rectangle. In short, the other side is also R. And this is not anymore capital R. This segment right over here is simply equal to capital R minus R. Now at this point, let's focus on this segment. What is the length of this segment in terms of capital R and R? This is just R, capital R plus small r, or simply equal to capital R plus R. Now, how about this segment from the center to this point? This is just capital R minus R, because the whole thing is the radius of this quarter circle. Now, let's focus on this right triangle. Since it is a right triangle, we can use the Pythagorean theorem. So to get the other leg, we can use Pythagorean theorem, and there it is. So this length is just the square root of capital R minus R quantity squared minus R squared. And now, we have here another right triangle. So using this right triangle, we can now use these three sides and get the relationship between capital R and R. So using the Pythagorean theorem, a squared plus b squared equals c squared, we have capital R minus R quantity squared plus the quantity square root of capital R minus R squared minus R squared quantity squared equals the hypotenuse squared capital R plus R. Simplify this equation. Now, if we expand this is the same thing as capital R minus R quantity squared. So we can double this term right over here. Now, combining like terms, we get that capital R squared equals 6 times capital R times R. And also, we know that capital R is not equal to 0, so we can divide both sides by capital R. This will give us that capital R equals 6 times R. And this is now the relation between capital R and R. So we now know that capital R equals 6 times R. So now, we can now get the ratio of the blue region to the green region. But first, how do we get the area of this blue region, or this? So in order to get the area of we need this angle. So if we get this angle, then we're done. Now the question is, how do we get this angle? Now, what we're going to do is to connect these two radii like this. And now, take note, if this is R, this side is also R because all radii of a circle are equal. And now, the question is, what is the length of this segment? Consider this quarter circle. This is also the radius of this quarter circle. In short, this is also equivalent to capital R. In short, this triangle right over here is an equilateral triangle. In short, this theta simply equal to 60 degrees. Now we know theta, we can now get the area of the sector. So the area of the sector simply equal to theta over 360 degrees times pi r squared. We know theta, we know capital R, this is 6 times r. So the area of the sector equals 60 degrees over 360 degrees times pi times 6r raised to the power of 2. Simplify, this is just 6 pi r squared. This is the area of this blue shaded region. And also take note that we know the area of the circle. This is just pi r squared. In short, the ratio of the blue shaded region to the green shaded region simply equal to just 6. And that is our answer to this question. By the way, this is the answer of the AI to this problem. So the ratio of the blue shaded region to the green shaded region is 3.26, which is quite short to the real answer. So the correct answer here is 6. And as always, we are done.